For multiplying scientific notation, I'm going to start by just writing a simpler example, kind of like your exit ticket yesterday. If I have a number, a base, and an exponent, a number, coefficient, a base, and an exponent, what we've practiced in the past was regrouping it and saying, okay, these are coefficients. I really need to figure out what 5 times 3 is. And then I have x cubed and x to the 5th. Coefficients work like they always do. 5 times 3 is 15. And then based on our exponent rules, we could write it all out, x times x times x, and so on. Or our shortcut is that we can add the exponents. If I were to write out x 3 times and then 5 more, I'd have x written out 8 times. We're going to be using that logic for multiplying these really large or really small numbers written in scientific notation. I'm going to multiply coefficients, add up exponents, and get a much easier final answer. For this first one, my coefficients 4.3 and 2, we're going to get 8.6. 10 to the 8th and 10 to the 6th, we're going to end up multiplying by 10 8 times, and then 6 more. We'll have times 10 to the 14th. One common mistake to look out for, sometimes people multiply these bases, 10 times 10, and they get 100. If we're thinking carefully about the expansion, we can avoid that mistake. If we just kind of know the routine, the procedure, I'm going to multiply those coefficients, add my exponents. This answer is still in proper scientific notation. What I'm going to do real quick is skip down to problem C. If I multiply 1.5 and 8, I know that that's going to be 1.5 of 8. So 8 times 1 is 8. Add half of that plus 4. We're going to get 12 times 10. I'm going to add up my exponents. -2 plus -1 is -3. And it seems like we have a final answer. It's really close. The problem that you guys saw in an exit ticket the other day, that number's too big. That's greater than 10. So what it really should be is 1.2 times 10. But now we need to adjust this. My advice would be to actually write the number out in scientific notation and then fix it. So if I had 12 times 10 to the -3rd, that decimal point needs to shift 3 times to make the number smaller. 1, 2, 3. I'll add in a 0 here, a 0 up front if I want to be really proper about it. And then to convert to proper scientific notation, I would only need to shift twice. So I'm going to make that a -2.